Hey, yeah, it's coming through, but you're real squeaky or something. Well, that's a little better. Okay. Okay. All right.
One, two, three, four, 5, 6, 7, 8, 9, 10, 13.
Do it again for me, Wyatt. Count to 10 one more time, please. We're having trouble getting the level off.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 30, 40, 50.
We'll have you take that microphone off, Wyatt. We'll give you enough.
Broke it already?
It's like somebody's going to be putting in hours paying for a microphone.
What do you do? Hey, does that look okay in the back?
Pretty well. I can hear you. Can you hear me? Good. Didn't mean to cut it quite so close there.
Mic check one, Nina. Could you please give us a mic check? Count to 10, please.
1, 2, 3, 4, 5.
Excellent. Thank you.
All right, phone's top.
Mic down.
I took it back to Janet.
Good job, Wyatt.
Let's get the lad's mic on.
All right, so you're always going to be up close to that. When you're on, you and I will just be talking right here. We don't have to worry about looking at any camera.
Okay.
Probably that one.
Count to 10 for me, Wyatt.
Probably going to be one on.
1, 2, 3, 4, 5,
Excellent.
6.
Thank you, sir.
I'll ask you.
Cool.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here today at the Agriculture Academy at McKinley Elementary School, and we're all here to... Do the Math!
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And we have Wyatt in studio, a 7th grade student. If somebody needs homework help, what do they need to do?
For math homework help, call in Bakersfield 636-4357. Toll free 1-888-636-6284. Our email is dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Do you have that many ways for people to get a hold of you?
No.
No, nor do I. Only here on Tuesdays and Wednesdays.
That's right.
But anyway, we do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year between 3:30 and 5:30. If you would like to see one of your math problems worked out on air, so you can watch it over cable TV or online, simply let one of the phone tutors know, and by all means, we'll see if we can work your problem in. That way you can see it worked out, maybe help you understand it a little bit better. Now, you're in 7th grade. Why don't you let everybody know where you go to school, first of all?
I go to Chipman Junior High.
And how is that?
It's really fun.
Why?
Because I'm on the football team, and I get to look
so
forward
it
to
has nothing
practice
to do
every
with
day.
school. It's because you're on the football team.
No, I like school too.
Okay. So what's the best thing about school this year?
I really like math class.
You like math class. What kind of math are you doing right now that you find maybe a little difficult than before? Or is there anything?
Not really. It just comes to me.
It comes
most
to you?
of the time, yeah.
Good. Go over to the board, young man.
We'll see if this one comes.
We're not even going to do the one that you brought for math homework because that's going to take a little bit of time. And we only have a couple minutes right now. All right. What I would like you to do is I would like you to write an exclamation mark up on the board. And on the left side of it, I would like you to put 4, the number 4. Do you know what that means?
No.
It means 4!
Hooray!
Right? I'm only kidding. But that is 4 factorial. Okay?
Okay.
So what I would like Scott to do with you right now is go over what factorial means and how you can evaluate 4 factorial to get what its value is.
Okay.
All right?
So that's what that exclamation point means in math. Factorial. Tell me what word you notice in that word. What part of that word you notice from math?
Factor.
There you go. So this is kind of part of it. So we're going to take pieces of that 4, but actually it's even more simple than that. Not even much math to do as far as breaking the number down. So if you were going to give me a factor of 4, what would it be?
2.
2, because 2 goes into 4, right? And 1 goes into 4 and all that fun stuff. This ends up being actually a little bit easier. So you start with the number that you have at the beginning there, 4, and now we're going to multiply this times every number all the way down to 0. But we're not going to use 0 because, of course, if you multiply those all out together, you'd end up with 0 as an answer.
Right.
So we're going to multiply that times all the numbers that go down to 0, the integers. Okay. So what comes after or right before 4?
5.
No,
or
right
3.
before. Right, 3, and then
2.
Yep, and then
1.
And you always put a 1 in there even though you don't really need it, but we want to show that we're going to multiply all the numbers down all the way down to 1. Okay? Think you can evaluate that for us?
I think so.
I think
So
so.
4 times 3 equals 12.
Mm-hmm.
And then times 2 equals 24. And anything times 1 equals whatever it was.
There you go, 24. So the factorial, no matter what number you put it after, can you imagine how big that gets if you say maybe did 17 factorial or 42 factorial or 123 factorial, right?
Yeah,
That gets
that's
really,
a
really
lot.
big. And so when you're goofing around with some math problems sometimes and they say you can use any operation you want, multiplication, division, subtraction, addition, square roots, which you probably come about, right? Exponents. And then there's this factorial one, and that really throws a wrench in things, but it also makes it really, really powerful. Just as a guess, which one do you think is more powerful? Exponents or factorials?
Factorials.
Well, that's pretty powerful, no doubt. I guess it depends which exponent you have
Right.
and what the base is and all that fun stuff. But they're definitely powerful, right? More powerful than addition, right?
Right.
So you can get some numbers up pretty quickly there. So you can be excited about it, just like the exclamation point says. But what it means in math is that you're going to multiply times all the numbers below that.
Okay.
There you go, nicely done. So something a little new for you right there is you're into 7th and 8th grade right now. So come on over here real quick. And so I just wanted to introduce you to that because it might be helpful in something that you use a little bit later on, possibly during today. All right? Anticipation, my young man, anticipation. We do have phone tutors available until 5:30. 636-4357 is that phone number, but it is now time for today's Math in the News. And our guest this afternoon is Juanita Recinos, and she is from the Boys and Girls Club. And how are you today?
I'm good, thank you.
Now, when students hear the Boys and Girls Club, they might be, well, there's a lot of them all over the place. Where do you work?
I work at the one at our Niles, and that is our headquarters for the one here in Kern County.
Okay.
And the one here in Kern County, fun fact, is our biggest in the nation.
Right, the largest one in the entire United
Yes.
States is right here in Kern County.
Even I didn't know.
Now, how long have you been at the Boys and Girls Club, and what is your role with them right now?
Well, I've been working there for 5 years, but I actually started as a member.
Okay.
Yes, but I am the program director at our Niles location.
And what does that mean for students? All right, you're a program director. What does that, like, what do you do?
So I do grant reporting, I oversee programs, our summer camps, all of our camps that go on there, our after school program there, and many other activities that our kids do there.
And there are a lot of activities
Yes.
that are available for the students, and that's why we wanted you to come in today. And we can see some of the activities right here. So they're doing, looks like kind of a marathon thing right there.
Yes, we do provide STEM opportunities for our kids. We have different arts as well, sports. We have dance. We have some of our clubhouses have ballet that go on there. We have seasonal sports actually too.
Okay. Now, I didn't know about the ballet.
Yes.
Now, so you're not only STEM, but you're STEAM because you've got the arts integrated into
Yes.
a lot of the activities
Correct.
also. And I know that a lot of students are getting into robotics, coding, and things like that, and then building things as they were right there. Are there any programs that are more popular with students than others?
Well, we have every Wednesday, we have our STEM mentoring that we have kids from the ages 7 to 12 that are part of that group. And
Okay.
then we have our teens that are from the ages 13 to 17 that actually mentor our younger kids and do all of that.
And is 17 the limit for a student to be with the club?
If they are 18, as long as they're still in high school, then they're fine.
Okay. And I know that there are, I mean, you guys have, what is it, like 50-something sites?
We actually have 62 locations.
62 now,
Yes.
so it's growing as
Yes,
I remember
we are
56 a little while ago or whatever. Now, I know that we brought you in because we wanted you to let everybody know about the Boys and Girls Club and some of the services that they provide. Is there anything in particular that's coming up that kids can go and check out the Boys and Girls Club, or any activities you have planned for members already?
Well, right now what we do, once a month, they're at my site, I do a health net cooking with kids. So I go ahead and open up the doors for our parents to come in, and we do different rotations where we teach them how to do like healthy cooking and things, something that's simple to cook up, because I know they're getting home tired and they don't want to spend all night cooking.
Right.
But healthy, that they can grow themselves, and that takes up to like maybe 5 to 10 minutes to make.
So you're not making pizza pies?
Actually, we did kind of make.
So you can make pie?
Yeah, you can.
Oh, good. Well, Wyatt, do you have any questions for Juanita while she's here?
How do you sign up to be a member of the club?
Well, you can go ahead and go into, if you're at a school site, we do have after-school programs at Chipman. So you can go ahead and ask to speak to the site coordinator there, and you can enroll. And at our clubhouses, you can go to either our Niles location or our Stockdale location, and you can walk right in, and the papers are there.
Sweet.
So there are a lot of schools that have sites associated with the Boys and Girls Club right at that site instead of going someplace else.
Yes, correct. So right after when they're out of school, they go and meet with their activity leader, and they don't, some schools get off at 6, some get out right after 6, and the parents can just pick them up right after school.
All right. You like working there?
I love it. I do.
I'm only kidding. I do. You got to say
I do.
something like that. But I know a lot of people that work with the Boys and Girls Clubs, and they truly enjoy what they're doing. I mean, it seems like people stay there also for a long time.
Yes.
And because of what they're doing and their love for the kids and the services they're providing and thing, I think is a great benefit when retaining people for that.
Definitely.
For the Boys and Girls Clubs.
Yeah.
There was one thing I wanted to mention also. I don't know if you're familiar with this or not, but I'll just mention it real quick. The 66 Club.
Club 66?
Right.
Yes.
Can you tell just a little bit about that?
So Club 66 is where someone is able to be a donor. So they donate, their goal is to do 66 members that donate $66 a month. And then that way it's able to, at the end of the year, round up and help out one of either our clubhouses or after school programs with funding.
Okay, and that's for some of the adults out there that may want to help out
Yes.
the Boys and Girls Club.
Definitely.
So 66 members, that's $66 a month. And is this something new or has it been going on for a while?
I believe it just started, it kicked off like at the beginning of this year.
Okay,
Yeah.
so one of the new programs with the Boys and Girls Clubs of
Yes.
Kern County.
Yes.
Well, we certainly do appreciate you taking time
Thank you.
to come out and enjoy a little bit
you.
of time with us and a little bit from the Boys and Girls Club, and that is today's Math in the News. 636-4357 is that phone number. We do have phone tutors available until 5:30, and right now we're going to go out and about, visit with Scott at McKinley School.
Hey, thanks a lot. We are here today at the McKinley Agricultural Academy, the after-school program here at McKinley Elementary here in downtown Bakersfield. I'm joined today by Mariah. Mariah, thanks for having us this afternoon. And Mariah who am I to, of course, speak over? You were offered to us as kind of the speaker guide to kind of navigate us through the outdoor learning space that you have here at McKinley. So this has been open for about a year or so. The Grimway people have come in and provide a lot of support on kind of upkeeping and building out this facility. So we'd love to see what you have available here.
You can't say
So let's go ahead and take a look and see what we have at McKinley. There really is so much as far as, things that are able to be picked off the vines, flowers that are growing, and even just in this kind of shaded workspace as well. You could tell a lot of care went into this area. So tell us a little bit about this space.
Okay, so right here is, I forgot what it's called because it's been so long, but we plant the fruits and vegetables over here so they could get small, and then we bring them all the way over there so we can make them bigger.
So this is where all of your sprouts really begin. This is where the seeds go down. You don't just throw them into the garden. You're going to go ahead and start them off into these care areas here.
Some of them are seedlings.
So this is kind of like the seedling nursery, and you can tell that there's a lot of thought that goes into this space. We have some of the sprinklers overhead to keep them watered, and it's not just for like the smaller sproutlings, it's for some of the larger trees that'll grow as well in that other side. So what kind of plants do we have just kind of in this general area here?
Well, we have spinach, red cabbage. We used to have broccoli here. We have regular cabbage. We have some other fruits and vegetables.
So mostly the edible components of what you're going to grow here. And it's interesting because you'll look at some of these and figure, well, they're just flowers. But even the fruits and vegetables have really vivid flowering capacities as well. So they've sprouted, they're good to go. We're ready to kind of get them in with the rest. So where would we go from here?
We would go over here to the worm composting pile.
She said worm composting. Okay, so.
And if you guys would like to stick your hands in here, you're more than welcome.
She challenged me, everybody. This is what I'm going to do for you at home, okay? So I feel like I should ask first, before I put my hand in, what am I putting my hand into?
So basically, it's just shredded newspaper, like vegetables and fruit from our garden, and worm poop.
Worm poop. Okay. Well,
Which is
I mean, you don't have to explain what worm poop is. I'm pretty sure our viewers at home are going to get that. But one of the things I'm also going to say is for our viewers at home, just to add a little bit more color, it is fairly warm as you dig a little bit further beneath the surface. Would you be able to kind of explain why that is? maybe it's best that we don't, ladies and gentlemen. But
You have
this
to
is
ask Miss Morris or Miss Johnson.
Oh, I'm going to ask somebody. Don't you worry. But one of the things I get the sense of, it definitely feels like the kind of soil you would purchase. And so I get the sense there's a lot of nutrients that you're preparing for the plants out in the garden that you'll use this for.
And then there's like lettuce stuff from our garden and tomatoes.
Now, I also understand that if there is leftover salads from the cafeteria, that they'll come over here as well, so you can leverage that instead of just throwing it away. That's wonderful. That's wonderful. That's really wonderful, everybody. So let's go ahead and move forward here. All right. So we have our raised garden beds here. After they've sprouted from seedlings, with the help of some of the worm poo compost, they'll start to really flourish in this area. So what's interesting to me as well is that every single one of these has a card built in, and we talk about the math component about agriculture. Just at a very surface level, you can kind of play around with it. So, for example, if we look at red radishes here, tell us a little bit about the sign that we have here.
So, of course, you can see it's red, but the stems, they're growing big, but these are like small, so we barely planted them like a few weeks or months ago.
So there's information here that tells you how to know whether or not they're ready to be pulled or harvested.
Yes.
So what am I looking for there? And according to the sign,
So, you see how it's like big and the leaves look strong and like kind of moist and whatever? Well, these, they're not so tall, they're not so wide and like in the picture. So once they're tall and wide, then we'll know.
So you'll know once they get to that space and they're long enough, according to this, about 5 inches long, you'll be able to harvest them. So it generally takes about 28 days to do so, okay?
Yes.
There's so much here to work with, and I know we're not going to get a chance to go that far in this segment here, but I also understand you have chickens here as well. So we have some purple top white globe turnips. There's a lot of variety in here, the kinds that you might see at like a farmer's market or at your supermarket, but you're making them right here at McKinley. What's your favorite part about coming to this garden?
I'd probably say planting the stuff
Why do you think that is?
because it's fun to just get like down and like do like, you know how you put the holes and stuff? I like to get dirty sometimes.
Well-
Sometimes I like to get dirty
That's
more
great.
than clean.
That's great to hear because I'm going to shake your hand and thank you, Mariah. Thank you so much. Remember, this is the hand I put in the compost.
I don't care.
Ladies and gentlemen, we're going to come right back with another segment and take a further tour around here at the McKinley Agricultural Academy. But for now, we're going to send it right back to the studio. Take
All
it
right,
away.
thanks for that, Devin. And nice to see that he is a sporting boy to be able to do anything that Do the Math asks of him.
That's right.
So never know where you're going to end up, what you're going to be doing on live shots like that and going out and about in the community. Hey, we do have homework help available for you until 5:30 this afternoon. And we have Wyatt in studio, a 7th grade student. And you ready to do one of your math homework problems?
Yes, sir.
All right, head on over to the board. We'll take a look at it on the camera right now so everybody can see what you're working on. Mrs. Ross needs to buy soap. There are 4 different size containers. Sort the brands from least to greatest unit price. Round the unit price to the nearest thousandth. So we can see on the right-hand side we have 4 different brands. Lots of Suds, Bright Wash, Spotless Soap, and Lemon Bright. And then we have the price, and they have prices per ounces, 4 ounces, and all of those are different denominations and quantities.
Right.
So what we'd like you to do is figure out the unit price and then put them in your graph from least to greatest. So
And this
how
is
would
the
you like to
classic.
tackle it?
This is the classic. Should I buy something from the corner store or should I buy it from Costco in the big gigantic size? Right. It's really hard to compare these prices because even though the prices go from least to greatest as far as the amount of money you would pay up front, the amounts that you have also go from least to greatest. So we would like to know what the best deal is. That's kind of what unit price is all about. So what do you think about unit price? What does unit mean in math?
Unit means each
Each, yeah. So we want to know how much each what costs.
ounce.
Each ounce. So we want to know how much per ounce, right? And the word per, right? Addition, subtraction, multiplication, division.
Division.
That's right. There you go. So I'll give you a little bit of room here, and we'll see if we can work this one out. Let's work with this lots of suds first. It says it's 98 cents for 8 ounces, or per 8 ounces. Can you do a division problem to figure out how much it is for 1 ounce?
Yeah.
There's 98 cents. That's right, and it goes inside because we want the money on the top as well, right? Yeah,
Right.
there you go. So where's the decimal go on the top part of the division problem?
Right there.
Good. Okay, let's see. Get it done. Now, remember, we're going to the nearest thousandth. We wrote that down as well. So you can go to to 3 decimal places, right?
Right.
All right, go get them.
So 8 goes into 9 once, and then you put the 8 down here, and that equals 1. 9 minus 8 equals 1. You're going to bring this down here. You have 18.
Good.
8 goes into 18 twice, which makes 16.
A little more room?
Just a little bit.
A little bit more room. Okay.
And that equals 2.
Good.
And then, so now we have 12.
Right.
And then we can add another 0.
Oh, good for you. So we didn't have quite enough spaces, but we're going to go ahead and add a 0. That's a good idea to
Right.
get to the thousandths place.
Then we can bring it down here. And that equals 20.
Okay.
And then 8 doesn't quite get 3 times into 20, so we're going to go 2 again.
Okay.
And that equals 16 still.
Okay, so we don't even have to do that part there, but you got it. That's exactly right.
Right.
So if you had to say this in money terms, what would it be?
12 cents.
About 12 cents per ounce, right? But they said it'd go to the nearest thousand, so we're going to go ahead and keep that per ounce. This is for our first brand, lots of suds. Okay, next one. Bright white, or whatever the BW stood for, right? You have $1.29, and we want to figure out how much per ounce because this time we have 12 ounces.
Right.
All right, go for it.
So you can't, we're going to put the decimal point
Good
right
for
there.
you. Yeah, it's always good to do.
And we can't make 12 go into 1, so we're going to put a little 0 right there.
Okay.
And then, but you can put 12 into 12.
Right.
So we're going to go 1's right there, and 12 goes down. And that equals 0. And then we're going to bring the 9 down.
Yep.
And we can't make it in there, so we're going to put another 0.
I'm so glad you have that space holder there with that 0 because a lot of times students will forget to do that.
Yeah.
All right, but then you have to bring down something else, right?
Right. So we're going to add another 0.
Good.
We're going to bring it down to this.
Okay.
And it's not quite 8, but it is 7.
It is 7. There you go.
So 12 times 7 equals 84.
We'll put that 7 up there.
Yeah.
Good.
And then 84. And then that equals 6.
Good. So if you had to tell us how much money this is per ounce, what would you say?
11 cents.
Good, because you rounded the 10 up to 11 because the
Right.
7 helps you round. So you can see if at some point in this problem we get 2 products with a very similar price, 12 cents or 11 cents.
We can go back to that
We can
last
go to
one.
the third place. That's right. All right. The next one we have is 314. I'll have you come all the way over here and do this one. And we want to know how much 30 ounces. And you can see that the division becomes a little bit higher
Yeah.
the further we go, right? Because we have bigger quantities. I'll even
Right.
give you the decimal point right there. All right. Go for it.
So 30 can't go into 3, so we're going to put, this time we're going to use an X.
Okay.
And then, so that we know that we can multiply times these.
Good idea.
And then 30 goes into 31 one time.
Yep.
30 times 1 equals 30. And that equals 1.
Good.
We're going to bring down this 4. And then 30 cannot go into 14.
So this is, again, one of those situations, yeah, you go ahead and put your 0 there. And you can see if we were comparing it to the previous product, we would definitely need to go one more place because we
Right.
don't know. That one looks like 10.
10,
This one looks
10.
like 10. All right. So what are you going to do now?
Annex a 0.
Yep.
We're going to bring it down again. And that equals 140.
Whoa. Now we're dealing with some big numbers.
Yeah.
30 into 140.
So I know that 3 goes into 14 4 times.
Good for you. I like the way you
So
did that.
30 goes into 40 4 times.
Okay.
And then we're going to put the 4 right there.
Good.
30 times 4 equals 120. And then
And so this product is
10 cents per ounce.
10 cents per ounce. So this is so far the cheapest one, right? But we
Right.
do have one more left. And we'll have to give us a little more space. Light bright, or whatever the LB stands for, 350 divided by 32. Here we go. 350.
That's lemon bright.
Lemon bright.
Don't
There we
forget
go.
the lemon is very important in this washing of dishes. So.
Apparently, yes.
You want
I
it to
haven't washed
smell
dishes
nice
for a while.
also.
Hooray for lemon. All right, let's see how much this stuff costs. $3.50 for 32 ounces.
32 cannot go into 3, so we're going to put that X there
There's
again.
your X, yeah.
32 can go into 35, so we're going to put a 1. And then we're going to put the 32 down here. Subtract equals 3. Put the 0 down there. it barely doesn't fit, so we're going to put that placeholder again.
And now you can see why we went to the thousands place,
Right.
right? Because we have 3 of them that have 10 cents with an extra place. So we'll be
Right.
able to compare them once you go to the last place.
We're going to annex one more 0 and bring it down. 300.
Yep.
And I know that it can't be multiplied by 10
Right.
because that would make 320.
320, yeah.
So we're going to go one less than that, which is 9.
Good. And now we got to figure out what 9 times 32 is.
So I just put it right here since this is the last one
little
that we have
scratch
to
work
do.
over there, sure.
8, carry the 1. 27 plus 1 equals 28.
And we made it under 300. So
Right.
that's all we needed to know, right? So if you had to tell us about this one, how much would it be?
11 cents.
11 cents. And the one that we had up the very first, right? That was all, or the second one we had was 11 cents as well. So we want to know, what is the least price? What is the lowest price per ounce out of all 4 of these products?
Right there.
All right. Do you remember which one that was?
SS.
SS.
I forgot what that was.
What was
So
SS?
SS was spotless soap.
You want to just go ahead and put SS there?
Sure. Where?
At the top, yeah. Spotless soap. And we found out that this one is 104, right? 10 cents per ounce. But we're going to go ahead and
Okay.
keep it in there.
Okay.
All right, what about the second one? Second place. We need to
Let's
look
see.
down there again.
Right here.
Right there, 12 and $1.29. Which one's that one?
Bright white.
Bright white?
Bright wash.
Bright
Bright
wash.
wash.
There you go.
Almost there.
Not all dishes
We're
are
trying to
white.
get that bright, that light bright in there somehow.
And then
And how much was that one?
was 10 cents,
With a 7 at the end, huh?
and then per ounce.
Yeah. Good. And then number 3?
Number 3 was right there,
Oh yeah, that was the big one.
and that was light.
It's not light bright. That was the one I was trying to get you. Lemon bright.
Lemon
Gotta
bright.
get that lemon in there. Okay.
And that one was,
Ooh, what was it? Sorry.
it's okay. Okay, so 10 cents
Okay. 0.109. Good.
per ounce.
Okay. And the last one?
The last
We
one
want to avoid this one
was-
anyway. It doesn't really matter the name because
Right.
it's the most expensive. So which one is it?
is-
I remember that one. Lots of suds.
And then that is 12.2 per ounce.
And what a great problem. I really like it when we break down this way because you can see that if you look at the original prices, it looks like lots of suds is the best deal. It's the cheapest price. It's the cheapest money out of pocket. But if you want to get more of a quantity, if you want to figure out how much it is per ounce of product, it actually is the least, it costs the greatest amount of money. And
Right.
it's not the best deal. The one that's the best deal is actually the next one up. So the important part to do this, and the wonderful part about, love to do the math part, but every once in a while when you go to the store now, you can see the unit price on a price tag, and it's in that little yellow box in the corner. I know a couple of stores are starting to do that. And if not, you can always bring your little pad of paper and do a little math in the store. Make sure you get the best deal.
Work it out yourself, a little consumer math right there. Nicely done, Wyatt, for your effort today. We'll award you with a couple of passes to any CSUB event of your choice. So a lot of sports going on right now, a lot coming up in the wintertime, and then, of course, all of the springtime sports as well. We do have phone tutors available until 5:30, and we'll be back with more right after this. Today we're at Gorman School, home of the Cougars, and we're here to Here we are at Gorman School. We've got some 5th and 6th grade students, and we're going to do a little bit with area and perimeter today. You guys know about area and perimeter?
Yes.
Okay, so I'm going to give you guys each a piece of paper, and we're going to do the backside that is blank for right now. All right? And what I would like you to do is you can take a colored pencil, preferably a darker color one, so the yellow may not work as well. Okay, so that way we can just kind of see what you guys are writing as we keep going. All right, everybody ready? All right, so on the back, let's write down the word area. A-R-E-A, area. Have you ever heard of this term in mathematics before? You have? What do you know about area? What do you think you know about it now about it? Like, what is the area of something, right? Have you heard of that? Have you heard of area and perimeter? They go together?
I kind of know what diameter is. I remember.
Okay.
Isn't it like, say we had a circle, isn't it like the distance from one point of the circle to the next?
Right, when you're talking about diameter, right? Okay. So we're going to talk about, think about a rectangle or a square. Okay. If we wanted to know the distance around this table, that would be the perimeter of it. But if we wanted to know how much area was right here in the middle of it, that would be the area of the table. Do you guys remember hearing about this? Area and perimeter? Mm-hmm. Okay. So let's go perimeter right underneath it. So P-E-R-I-M-E-T-E-R. So area and perimeter, that's what we're going to be working with today. All right. If I draw a figure on here, I can have the length and the width. You guys have seen this before, right?
Like X and Y?
X and Y. You can label it whatever you want, right? So you have length and width, okay? If I say that this side is 4 feet long and this side is 4 feet long, can I figure out all the way around it?
Yeah.
How do I do that?
You do 4 times 4.
Okay, I could do 4 times 4 because they're all the same.
Yeah.
Right? Is there another way I could do it?
You can add them.
I can add them, right? I can just go 4 plus 4 plus 4 plus 4, right? Because if this side is 4, what's this side going to be?
4.
4. And this side is 4, this side's going to be 4. Okay? So the perimeter is the distance around something. Okay? The area is all of the shaded in part. Okay? Now if I add all these up, what will I get?
16
16 what?
feet.
Feet. All right? So we get 16 feet. Do you all agree with that?
Yes.
Now if I want to do the area, I'm going to multiply the length and the width. If I multiply the length and the width, what do I get?
16.
16, right? But now it's 16 square feet, right? Because if this was 1, right, if we filled them all with squares, they would be square feet. You guys have worked with this before?
Yeah.
All right. So a little bit about area and perimeter on the first session with some students from Gorman School. And a big thanks to the staff and students at Gorman, because it wasn't our first time up the hill, but our first time to visit with the staff and students at Gorman School. So thank you once again. We had some fun with those students. We do have phone tutors available until 5:30. We have Wyatt in studio, and you know what? Today is a big day, because today and tomorrow, any students that phone in to do the math will be eligible to win themselves a ticket to the Kern County Fair. And I know that you guys will be going to the fair because you have yourself a ticket for being in the studio today. So today and tomorrow, any students that phone in, you will automatically receive your ticket to the Kern County Fair. Right now, we have another opportunity to go out to McKinley and visit with Devin once again and see what they're doing.
Hey, thanks a lot. We're back here at the Agriculture Academy at McKinley Elementary School. We just came back from the Garden Center, and now it's time to put all those wonderfully harvested products to good use here in the kitchen lab. So, as part of this station, all those kids that were just part of the gardening process are now going to actually develop a recipe using the materials that they have been working with. Today on the menu are spring rolls using lettuce as the wrap. We checked in with Mariah, who's a wonderful guide with us before, and she's going to join us as well as Deltavius to talk a little bit about what exactly it is that they've been working on. So they're getting their instructions right now. and you can see them working with mint. So, one of the great things about the Academy here is the sense of getting a real true feel for those ingredients. Yeah, maybe we've had mint before, but have you ever had a chance to actually hold it and see what it feels like, smells like, before you put it in as a component of your spring rolls? So we're going to go ahead and check in with Mariah here.
The way we're going to do
Mariah,
this.
tell us a little bit of what you've got in your hand right here.
Mint.
So have you ever held mint before?
No.
This is a first. What are some of the things you've observed about mint holding it?
It looks like it's pokey, but it's not.
It's got very fine points on the leaves as well. Have you had a chance to smell it? It's very important, right? We definitely want to know what our ingredients smell like and taste like. Go ahead and pick one of the leaves off and give it a taste here. Leaves are one of those herbs that we can taste. And you can actually even chew it as well. Mint's a very popular flavor in gum, but when we chew it, it's very strong, right? But that's why it gets diluted a little bit as an ingredient as well. So mint is going to be one of our ingredients, and it looks like we have quite a bit in here as well. So Deltavius, tell us a little bit about what we have in our mixture so far.
We have carrots, rice noodles, cucumber, radishes, stalks, and a bunch of claritos, cilantro.
So it sounds like you also had to do like a little bit of a substitute here, right? You were going to use cucumber, but what did you use instead of the cucumbers?
Carrots.
Carrots, okay. So there's a lot here. And now I see these are called lettuce spring rolls. So how does lettuce come into play in all this?
Don't touch your fingers. Lettuce as a taco shell.
So it's kind of like so the spring roll's going to kind of be in like a taco form where you're going to kind of wrap it around, almost like you would with a tortilla. So the mixture is being placed together right now. Everything is coming together as all of the ingredients, maybe we interact with them a little differently, but the stirring process is also very particular as well, right? Because I think when a lot of people think about stirring, it's just like moving it, but that's not necessarily stirring here. So how would you describe the kind of stirring you're learning about here?
You pick it up and turn it.
It's more like kind of a toss and push than it is just kind of a swirl like you would if you were making chocolate milk here. Would you be able to model that for us a little bit here? Kind of show us a little bit about how to do that? So picking up and toss and turn it over, getting that rice noodle carrot blend in there. Everything is chopped up really nicely. I saw you got a chance to kind of chop up some of those rice noodles. What did you use to do that? Did you get the big sharp knife to do that?
No.
What did you get to use with that?
I got like those pinchers
So
and chop them up.
So when you say pinchers, what do they kind of remind you of that you've used before?
Like the tools that we use in garden.
Okay, so they're very similar as far as kind of what you'd use to kind of cut some things off, right? Is there anything in your classroom that you could compare them to that they kind of look like?
Oh, scissors.
Like scissors, right?
Yeah,
So
I could
have you ever imagined using scissors to cook or to prepare food before? It's kind of a new process, but it's something that professional chefs are very familiar with.
They use scissors.
Yeah,
Why do they use scissors?
well, to chop up food quickly instead of having to use the knife.
Oh, so the knife, because you gotta like chop it up, and it's like harder. But with scissors, you just cut it.
Absolutely, and you get the job done. Hey, wonderful. So we're going to try some of these spring rolls a little bit later on as we continue on here. In our next segment, we're actually going to go investigate as we visit the forensics lab. But for now, we're going to send it back to the studio. Take it away.
All right, thanks for that. Nice to see the kids reaping the benefits of their growing the food out there also. We do have phone tutors available until 5:30 this afternoon, and we have Wyatt in studio, a 7th grade student. And right now we're going to go to the phones for another 7th grade student. Caitlin, how are you this afternoon?
Hi.
Hi, Caitlin.
You doing well?
Yes.
All right, as soon as you're ready, let's hear the math problem you're working on.
The mean of a set of 5 numbers is 3K. When a 6th number is added to the set, the mean increases by K. What is the ratio of the 6th number to the sum of the first 5 numbers? Express your answer as a common fraction.
Okay, so the mean of 5 numbers is 3K.
Yes.
Okay, so we just want to make sure that Scott's got everything down first. So when a 6th number is added to the set, the mean increases by K.
Yes.
What is the ratio of the 6th number to the sum of the first 5 numbers as a common fraction? So as soon as he
Yeah.
has everything written, I think you can go ahead and kind of explain what you would like to do.
Wow, Caitlin, where do you want to go with this problem? This looks like a lot of fun.
First, I want to find the mean of the set of 5 numbers.
Okay. And tell us about the mean. What does that word mean?
The mean is where you add up all the numbers that you have,
Right.
and then you divide by how many numbers you have by what you get as the sum.
Gotcha. So if you were going to add up all those 5 numbers, right, then you would get this, this 3, well, you had the mean was 3K, right, but you had 5 numbers, so you'd have to multiply that times 5 to get the total of all the numbers, right? 3K
Yeah.
times 5. Wow. Okay, so I like how you explained that. Where do you want to go from here?
I have n for the sum of the set of 5 numbers. So n divided by 5 equals 3K.
Ah. Okay. So I like you're bringing in another letter here. Sometimes this really freaks students out. But I'm glad that you did this because it's important to be able to have another way to relate the numbers together. We've already used this number K, right? We don't even know what K stands for, but we're going to find out pretty soon. So I wrote in an equation form what you said. If you took n is the sum of the 5 numbers, and if you took that sum of the 5 numbers and divided it by 5, then you would have 3K, which is exactly what the mean is. Okay, so I've kind of written that down a little bit. What's next?
I'm going to multiply each side by 5.
Yep, multiply each side times 5. And I think you have probably said this better than I did at the beginning, but we're both ending up with the same thing. What do you get? N equals what?
15K.
15K. Good job. And that's what I had over here as well. So we're both on the same track. Good. So at least we have an expression for the letter N. What else do you want to do with this? We got to do something with this 6th number, right?
Yes.
Okay.
So I did n plus x for the 6th number.
N plus
Divided.
X. Oh my gosh. Now we have another letter in there. Okay, so we don't know what that 6th number is. So you're going to call the 6th number X, right? And your N was the sum of the first 5 numbers. So this is the first 5 plus the 6th number. Go ahead, and then divided by what?
6.
Divided by 6. That would be the mean of those ones, right?
Yes.
Okay.
Equals 4K.
Good. And that 4K came from here. We had the original total, and then it said it was increased by K. So that's where that came from. Boy, this is a lot of stuff here, but I think you're explaining it so well. What are you going to do next?
I'm going to multiply each side by 6.
There you
to cancel
go.
out the 6.
Yeah, get rid of that fraction there. Okay, so then you have N plus X on the left side. What do you have on the right-hand side?
Equals 24K.
24K. Now, I know where you're going with this because I really have thought about this problem a little bit, but can you tell us where you are going with this? What is your goal in simplifying this expression over here on the right, or this equation?
I want to get 15K equals 24K minus X.
Right, and the reason you want to do that is over here on the left-hand side, do you see how you have the N equals? And over here on the right-hand side, that's also what we'd like to have, right? We'd like to have N equals. So if we could get to the point where we would have N equals here, then we could use some substitution. This is a really fun problem. So how do you get N by itself over there on the right-hand side? Right now we have N plus X equals 24K. And you were about to say what? Minus what?
I changed it into N equals 24K minus X.
Ah, yeah, and you're taking that X away from both sides. That's it. So we have 24K minus X. Now again, I don't want people to get too scared about all this stuff, but here's the deal. If you have, let's take a real simple example. $1 is the same as 4 quarters. And $1 is the same as 10 dimes, right? So that means 4 quarters are the same as 10 dimes. We can just take out that dollar part. That's exactly what's going on here. If N equals 15K, and N also equals 24K minus X, what we can do is cross out these N's. We don't need these N's anymore, and we can put the other two things equal to each other. In other words, we can take this whole thing and bring it right here. 24k minus x. This is truly the power of algebra. Okay, so we have them equal to each other. What do you want to do with that?
Minus 15k from both sides.
Okay, minus 15k from both sides.
You want me to slide that down a little bit?
If you wouldn't mind, that'd be great. I tried to do it
on this
myself, and I
side
think I
now.
goofed
There
it.
you go.
Thank you. Okay, so what do you have now?
X equals 9k.
All right, let's see here. We certainly have the 9k here. And I didn't move the x yet, so what I ended up with is 0 on the left-hand side. But I see where you're going with this. I want to go ahead and add the x to both sides. And you're right, x equals 9k. Woo, that's a lot of stuff. Now, it's not quite what the question asked, but we certainly have a lot more information now. What was x again, way back up here? It was the 6th number, right?
Yes.
Okay, can you read the very last sentence of that question? What did it ask us?
What is the ratio of the 6 numbers to the sum of the first 5 numbers?
Gotcha. Okay, so we have those two things, right? We have the n, the sum of the first 5 numbers, and we have the x, which was the 6th number, right? All right, Mike, can you go down for us just a little bit more again? All right, so here we're going to make a ratio, and a ratio is a fraction, right? Can you tell us what that 6th number is? What is x equal?
9k.
That's it, you got it. And what is the sum of the first 5 numbers? What do we find out that is, right here?
15k.
You got it. So we have a ratio here, and you can see it's really nice to have a ratio when it has the same letters in there because you can go ahead and cross it off, right? So we're going to cross off the k's, and now we have 9 over 15. Caitlin, how do you reduce that ratio?
Divide the 9 and the 15 by 3.
I like it. And what's your result?
3 over 5.
3 over 5. So this is the ratio of those two things, and as archaic as that problem sounded at the beginning, it actually ends up being nice and smooth at the end. Good work there.
Nicely done. Great problem.
Yeah, that was a good
And
one.
for your efforts today, you'll be awarded a ticket to the Kern County Fair. So congratulations on that. We do have phone tutors available until 5:30. Wyatt's been hanging out. I think you're ready to do a little more work, aren't you?
Mm-hmm.
All right, let's erase that board over there and get you working, young man. All right, here's some more of your homework problems. So we have 2/3 times 1/6. So what I would like you to do, first of all, Wyatt, is do that mental math that you can do so well.
Okay.
Just mentally. Just tell us like, what you'd have there.
2 over 18.
Now, how did you get 2 over 18?
I multiplied 3 times 6 and 2 times 1.
And is that the final answer?
Yes.
Can you do anything with that answer?
Oh, sorry. And then you divide this by 2.
Good.
And then you get 1/9.
Perfect. Now, the only thing I want you to do is I'm going to introduce you to a new mathematical term, simplify, instead of reduce. The reason being because if you reduce something, you're taking some of the quantity away. If you simplify, you're keeping the same quantity written in a different form. Does that make sense?
Yes.
Okay. So we're going to simplify fractions, not reduce them.
Okay.
All right. Now, you could do that mentally. What I'd like you to do is show some students how you could do it, not mentally, but by simplifying the fractions first before getting an answer.
Okay. So we're going to write this out again. So what you can do is you can find the common numbers. And so these can both be divided by 2. And divided by 2 equals 1. And so we're going to X that out. And then divided by 2 equals 3. And then X out that out.
Gotcha. So you're kind of eliminating
Right.
this middle step and doing the division part as a part of the beginning of the problem.
Right.
I like it. Okay. So what do you get as a final answer here? Hopefully the same thing, right?
Yeah. And so you just multiply straight across, and it equals 9. And 1 times 1 equals 1.
Yep. There it is.
Nicely
Good.
done. Let's take a look at the other problem because this one's a little different now. So we have 1/4 divided by 3/8. So if you would be so kind as to explain to us how you would solve that problem.
So first, you would flip the second number, and that would get you 8 over 3, and then you'd still have the 1/4. But instead of dividing, we would be multiplying. And so now you multiply straight across. 8 times 1 equals 8.
Can you simplify first?
Oh yeah.
Well, let's let him do this first.
You can do that,
Okay.
sure.
We'll make sure.
And then 4 times 3 equals 12. And then you can divide both of them by 2, but instead we can divide both of them by 4. And then that equals 2. And that equals 3.
Oh, I thought you were going to do by 2 and then
Good.
by 2 again.
Oh, you can go
Not
by 2 and 2 and
again. So what was the way you wanted to simplify now?
So you could simplify first by having the 1/4 8 over 3. You can these ones are both already simplified, but you can do both of these by 4, and that equals 1, and divided by 4 equals 2. And then now you multiply straight across, and you get 2 over 3.
Good. Nice job.
Nice
Wow.
work. Now, one other term that you probably have heard this before, and maybe Sky, you can help him out with this.
Sure.
But you said you have to flip the fraction.
Right.
So talk a little bit about the vocabulary with math instead of saying flip and what they'll use in mathematics.
What's that word when you flip that fraction over? Have you heard that word before? It's a really fun word. And if you can,
Reciprocal.
Hey, there you go.
Reciprocal.
Yeah. Reciprocal. And that's kind of a neat word to use. Not only is it the correct terminology to use, but it makes you sound really smart if you know how to say it. Know what it's all about. Yeah. So when you say reciprocal, that's exactly what it means. Take that fraction and flip it over. And that's done because, is there any other way that you know of to divide fractions? You can't just go straight across like multiplication, right? But we do know how to do multiplication, so if we can make that division into multiplication, it works out awfully well.
So let's add another mathematical term now, shall we? Because we went from division to multiplication, so you're doing the blank operation.
So multiplication and division. If we're going to compare those two, what are they to each other?
Opposites.
They are opposites, yeah. That's one way to say it. What kind of operation are we doing on each other? They are the... Starts with an I.
And you may not have heard this term before, which is why I want to go over a little bit of these.
VE? RSE. What's that word?
Inverse.
The inverse operation, yeah. So you know how you go upside down and you get inverted, right? You flip it over. Same type of deal. When you have multiplication and division, if you change one to the other, it's the opposite, right? But you're also flipping it around, and the inverse operation is one way to say that.
There you go. Great vocabulary, reciprocal, inverse operation, and don't forget your big one of the day, factorial.
Oh, yeah.
Hey, you know what? We have one more opportunity. We'll go visit the students in Devon at McKinley School, see how they're wrapping up.
Thanks a lot. We're back here at the Agriculture Academy at McKinley Elementary School, joined right now by Caleb as we take a look at the forensics lab. That's right, forensics lab. So, Caleb, tell us a little bit about some of the work that goes on in this space here.
We do a lot of science stuff, and we do fingerprints right now.
So when you say you do fingerprints, what exactly are you doing with fingerprints?
Right, we're trying to find the crime.
This is crime. Everybody, stop. Okay. Do not call the police. There has been a crime, but we're on top of it. So, what kind of crime has been committed?
It's like pulling like trash and who's eating the candy and all those stuff.
Somebody's been eating candy out of the trash, and we got to know who it is. Who's eating dumpster candy? All right. This is our mystery, ladies and gentlemen. Now, we have some evidence, and you mentioned it was fingerprints. So, let's take a look at some of the prints that we have to work with to solve the dumpster candy mystery.
These are all the suspects, and we need to match them. That's it.
So, we have some samples from potential suspects, but we have an actual fingerprint that was left behind at the scene of the crime. So, let's see where that is.
So, who spilled the soap and who drew on the board?
Okay, so do we have the actual fingerprint to examine?
Yeah,
to see what
we have a
compared
picture.
to? Oh, we have it. Okay, documented right here. Look at that sinister fingerprint. Some criminal mastermind, and we're staring right at their thumb or their pointer finger remnants. So, based off of this, how would we use what's been left behind to help us identify whose fingerprint that is?
To look at the circles and all those stuff.
Okay, so which of these features really stand out to you that we should look for in our sample here?
I think it's Adam?
Adam! Oh, that Adam. I knew it was him. So what tells you that this is Adam's fingerprint here?
Because there's a circle thing right there.
Okay, so we have a central swirl. We have a central swirl here. Are there other features that might exist here? Because I see some other fingerprints that have a central swirl here.
Because there's like a little curve.
Okay, so we have an additional curve, kind of like we'd see over here on the side. So it could be any of these. So we can eliminate some that don't have that central swirl, right? So for example, I'm looking at Jeremy here, right? Jeremy doesn't have a swirl. It kind of like loops outwards, so it's not circles around that. Jeremy, you can sleep well at home tonight. You're off. What about Fran here? Same thing with Fran. She didn't do it because look at her fingerprint. It doesn't have that central swirl here.
Yeah.
Who else might have that central swirl here that maybe we're overlooking?
Betty?
Betty! Oh, I knew it. Betty was too good to trust, right? She's got kind of that central. So you're using some of the things that you notice to identify some of those patterns to help narrow it down and eliminate them. So this kind of sounds a lot like problem solving to me. When we think about math, we usually just associate it with numbers, but there really is a lot of problem solving and reasoning involved. So how do you use some of those skills in this kind of activity here?
To like, what's the name? That we need like lines and it's hard to work and we need to see if there's curves. And
So it sounds like you're looking for patterns
Yeah.
and you're making observations. And that's kind of what you do in math, but it's also kind of what you're doing here as well. So you have some other things you're looking at as far as other mysteries here, right? Like it's not simply just like who's eating garbage candy. It's also maybe who left some material on here in the lab, right? Or maybe who broke a chair. Or the most sinister of all crimes, who was eating food in this STEM lab? I mean, because you guys have food that you make everywhere, but who is eating it in the lab? You don't do that here. How do you think this sort of activity kind of helps you maybe with other subjects in school or beyond that?
it helps you learn and that like it helps math and stuff and history.
So you think there's a component of history? I think it's interesting that you mentioned the connection between math and history, because that's not something that a lot of people generally do, but it's something that personally I'm really passionate about, because they were doing math thousands of years ago. And the ways that they were doing math thousands of years ago, we could still use that today. And it has an immediate application and connection with what we do. So that was really insightful to hear from you, Caleb. Hey, thank you so much for guiding us around here, and hopefully we get to the scene of this crime and figure out who ate that dumpster garbage trash candy once and for all. Caleb, best of luck to you on your investigation, sir. I salute you. We're gonna come back and wrap things up here, but wonderful experiences here at the McKinley Elementary School Agriculture Academy. So many wonderful things to really explore in education, and it's an honor to be able to see this firsthand. So we'll send it back to the studio. Take it away.
All right, thanks for that, Devin, and thanks once again to the staff and students at McKinley Elementary School. We do have phone tutors available until 5:30, and for Wyatt coming in and doing some great math this afternoon, we've got yourself a gift card courtesy of our friends at Chick-fil-A, so congratulations on that. You eat that? You like that Chick-fil-A?
Yes, I
That's
do.
good stuff. Old man, he sat up too, I'll tell you that. And, as always, for coming in and doing great work, you now have a uniform. You are another ambassador for Do the Math. You cool with that?
Yep.
I need you to shout it loud and proud, everybody, about Do the Math. So if somebody wants to know how they can get some help, all you have to do is remember at the beginning when you read that off, tell them all of that. You can remember that, right?
Yep.
There you go, boy. All right. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District. with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.